Today we're going to talk about angles of polygons. So a polygon is a shape that we're pretty familiar with, like a triangle, a rectangle, a square, a pentagon. And each of these are going to have different interior angles of polygons. And that's what we're going to talk about today. There's also exterior angles of polygons, which we'll talk about as well. All right, so interior angles, the angles that add up to the inside. And what we have is a formula where we take the number of sides minus 2 times 180. So if we look at the first example in the chart here, we have n equals 3. That's the number of sides. So this is a triangle. And so if we do 3 minus 2, that gives us 180 times, 3 minus 2 is 1, times 180 gives us an interior angle amount of 180 degrees. If we look at n equals 4, this would be a rectangle or a square or a trapezoid, any type of quadrilateral, and that's the unit that we're talking about. So this will be something we come up and use quite a bit. We do 4 minus 2, which is 2, times 180 gives us 360 degrees. And we see that the change is we're adding 180 degrees to it. If we go to a pentagon, which is 5-sided, it's 5 minus 2 times 180 would give us 540. So again, the change between these is 180. So take a wild guess what 6-sided would be. It would be, we would add 180 to 540. And in the formula, we would do 6 minus 2 times 180, and that would give us 720. So we can use this pattern or the formula to figure out how much, for example, 7 sides would be equal to. All right, now what happens if we want to find the number of sides? So in our equation here, we have n and we have the degrees, the angles inside. There's two variables here. So in this example that we just did, we were trying to find the number of degrees when we were given the number of sides. In this example, example 2, we want to find the number of sides. So what we're going to do is use n as our variable and then take the degrees and plug it in on the right side of the equation. So the first step, what we're going to do is divide each side by 180. So if I take minus 2 divided by 180, we get rid of 180. 900 divided by 180 would give us 5, and then we add 2. So these two steps right here is how we end up doing this. So this would be something to write down. So in this case, the polygon has 7 sides, and this one has a special name called a heptagon. All right, next, so here's a practice problem in your notes. How many sides are in a polygon totaling 2,340? Well, in our equation setup, we put 2,340 on the right side. First step, we divide by 180. That would give us n minus 2 equaling to 13. And then we add 2. Okay, and that gives us a total of 15 sides. All right, next, some vocabulary here. So this is one example where we call something equilateral, like an equilateral triangle, for example. This would be where all sides are congruent. Lateral refers to sides. In an equiangular polygon, all angles are the same. And we see that because of the symbols inside. All sides are congruent because we see congruency marks. We could also see side lengths measured or something along those lines. Now, if we combine both of these, this is what we call a regular polygon. So it's a polygon that is equilateral and equiangular. So it has both properties in one. And that becomes pretty important. And we see this term regular come up often. So how do you know something's regular? If it's equilateral and equiangular. All right, so here we have a baseball plate. Is this thing is the polygon regular? So again, what's the definition? We go back to here. It needs to be the same side lengths and same angles. And if we look, we notice that they are not all the same angles. So right away, we know that the polygon is not regular. Okay, they do want you to find the measures of the inside angles. So for example, these two are 90. These three are 90. So we need to find what angle E and C is. Well, how many degrees does a pentagon have? A 5-sided shape. It has 540. And how do we do that? We do 5 minus 2 times 180 would give us 540. All right, so once we have that, we go to the next part. and we see that we have x plus x, so that's angle E and C, plus the 90s is going to equal to 540. And when we combine like terms and divide and move the variables, we get 135 degrees each for angle E and angle C. All right, one more problem for you guys. Now, this is the exterior angles. So now the inside angles, we have a formula, but the exterior angles, no matter what shape it is, it's always going to add up to 360. It could have 100 sides, but the exterior angles are going to add up to 360. All right, so here's an example where we have 1, 2, 3, 4 exterior angles, and they're going to all add up 360. So if we add them up individually, combine like terms and divide, we get a value of 360. So this in red right here is the steps on how we do this. All right, so this is a quick summary. We have interior angles, we have exterior angles, we have formulas, we have steps that you need to learn how to do. So go ahead, rewatch the video, slow it down if you need to. And that is all for today.